Can you just explain to the audience how BotBuilt's robotic framing system works? Let's say just from inception of a project to a finished product.
When we were starting, there were kind of two foundational ideas. One is the American consumer wants their home. They don't want just a house. And so that drove us to build technology that can accept any floor plan. We can give you a very accurate material takeoff for a house in under 24 hours. Right now, lumber yards take somewhere between 2 to 4 weeks to do that. And so we've actually...
What if robots could solve the construction labor shortage? Not in the future, but right now. Imagine framing systems that built with speed, precision, and efficiency, working right along crews on active job sites. In this episode of the AEC AI and Tech Strategy podcast, we're speaking with Dr. Barrett Ames, co-founder of BotBuilt with a PhD in artificial intelligence and robotics. He'll walk us through how the robotic framing systems operate in the field, what it takes to introduce automation into a hands-on industry, and how their experience and why Combinator helps shape their scaling strategy. We'll also talk about how builders are responding to this shift, what real-world implementation looks like, and what the future could hold when technology and tradition work hand in hand. If you're an AEC leader looking for smarter, faster, and more efficient ways to build, this conversation is for you. But before we jump in, I want to tell you about our AEC PM Connect Event, both for project managers who want to improve project delivery, communication, and leadership through practical sessions and tools. These events provide an avenue to connect with leading PMs in the industry. Visit aecpmconnect.com and register today. We currently have events in Kansas City and New Jersey with more coming, and I hope to see you there in person. With that, let's jump into today's episode.
Strong leadership drives strong projects. Become an AEC PM professional and give your team the leadership skills they need to thrive. Customized PM development, premium content, and a leadership edge that sets you apart. Learn more at aecpm.com.
All right, it's now time for our conversation of the week with Barrett Ames. Barrett, thank you so much for taking the time to join the show, and welcome.
Yeah, thanks for having me. It's great to be here.
Absolutely, and as we were just talking about, right? So, I've known of Barrett, his company, and kind of what they've been up to, but there are a couple of pieces of media that really made it click for me, which is what had me ask Barrett to join the show here. So Barrett, I'll let you share a little bit about yourself and then your current role at BotBuilt.
Sure, totally. Yeah, I've been building robots for a long time. When I was 7 years old, I came running downstairs one morning and I said, "Mom, I just want to blow stuff up." And she said, "You're going to robot camp." So I've been building robots since then, did my undergrad at Cornell in mechanical engineering and computer science. Chose Cornell because they let you do whatever you want for your degree within reason. So I took all the things in computer science that I didn't need for robotics, threw them out, like operating systems, who needs to know about that, and substituted in a whole bunch of mechanical engineering. After Cornell, I got to do two really cool projects. First was Robonaut 2, which was on the International Space Station. Crazy thing there is astronaut time is $50,000 an hour. Rocket fuel's expensive. And they spend 5 to 6 hours a week cleaning their rooms. So we taught Robonaut 2 to do a little wipe down, a little vacuum. Paid off $1 million robot pretty quick. After that, I got to work on Valkyrie, which was NASA's first bipedal humanoid robot, part of the DARPA Robotics Challenge. We went from blank sheet of paper to a fully functioning robot in 18 months. And it was a hell of a ride. Learned a lot. Shot some plasma across the room a couple of nights. So we built it in the Apollo capsule clean room, which was super cool, but no red spectrum in the light there. So you'd leave work and your eyes would just be all messed up. At the end of my time there, I got to do some footstep path planning for Atlas from Boston Dynamics. And then I decided I was tired of all these people with letters after their name telling me what to do just because they had letters after their name. So I came to Duke, did my PhD in artificial intelligence and robotics, specifically focused on that long-term horizon task planning problem, right? So how do you take a robot and all of its geometric information and do something that takes significant planning thought? And at the same time, my wife and I bought a terrible house and started refabbing it. And that's what really exposed me to construction, right? Like, as you're remodeling everything, you're tearing stuff out, you're rebuilding stuff. And I started to see a lot of regularities that like 15, 20 years ago, robotics could not handle. But now, with parts from my thesis and then also just advancements that the field has made, we could really start automating home construction.
So when you talk about like a long-term problem that requires a lot of planning, incredibly
Right.
manual, varies project to project,
Yep.
right? We're talking, construction. Not that it
Right.
can't be automated. It's just that's not really
Right.
the way it's done traditionally. So
Right.
we have a little bit of the backstory on the inspiration behind on BotBuilt. Would you mind going into more detail there?
Yeah. It was just, I remember distinctly I was in one of the bedrooms sitting on the floor surrounded by just open walls, right? Studs everywhere. And I was putting up drywall and then I was putting in flooring. And I was just like, you could say I was frustrated. There may have been some cursing involved, but I was like, why am I doing this? Right? Like, this is a great task for a robot. And then a week later, my wife came to me and she was like, I'm pregnant. I was like, that's great. I now have a strong deadline. I need to finish a lot of this stuff. So I started paying people to help me with all of the tasks that I had left in the house. And I realized I had made a fundamental miscalculation in the economic value that the trades have, right? Because for my entire life, I was told, go to school, get a degree. Grad school is a great idea. It's how you're going to make all the money. And then a plumber came and did 2 hours of work and said it was going to be $400. And I was like, oh, this guy's got me. I've totally, like, my computer science PhD, like, $200 an hour is a good rate.
And you would think, right, for all of those people saying, hey, like, don't get into a trade, don't get into construction, that I don't know, some of the fundamentals of modern life, like running water or electricity, are I thought we put a pretty good price on those, right?
Right. Yeah. And so it was really those kind of two things paired together, right? Like seeing firsthand what's required to build a house, and then seeing the economic value that these guys can get, because they're the only ones left, right? Like there's the chimney needed some refab, and so I called around, looked. There's only one brick mason in all of Raleigh. Jose Jesus Ledesma, dude's a beast. Like, came in, did everything, wonderful craftsman, but like, he's the guy. If you need something done, it's just him. So, that it's crazy to me how constrained the trades are. Last year I was talking to the guy who does the electrician examination, license examination. And he told me that in North Carolina, there are only 3 licensed electricians under the age of 30. I was like, what? Like, there's some serious labor shortages coming down the pipe.
So we've got the backstory, right? Like you're sitting in the bedroom, walls are open, you're looking at studs, like what the heck did I just get into? So that leads you to BotBuilt, right? Now you're trying to tackle, again, what is considered a traditional industry, super manual. Hey, this is the way we've always done it. So what are some of those early challenges, right? You're getting the company started up. You're trying to, right, build homes of the future. What are the first couple of roadblocks you run into?
Yeah. I think the first roadblock, and maybe the biggest roadblock, is that, like, as a technologist, I thought people cared about technology. They don't care. They just want the job done. And so there was a lot of stuff that we spent a lot of time thinking about. And then when we would just give them, like, all right, here's the panel book. That's what we call, like, our layout of where all the panels go for a house. They're like, this is great, cool. And then we gave them a stack of the pre-framed wall panels, and they'd just stand them up and go. And, like, no questions asked, they just went for it. And so it was really like picking the right abstraction, right? Like the right entry point is really critical in making sure that, like, construction as it is right now doesn't have a problem adopting whatever your technology is.
And that is a really excellent point, Barrett, and one that I can relate to. So as like just a young engineer thinking that it's like other people would find this technology so cool, right? It's the best thing since sliced bread. Guess what? I would say like the human mind or the customer's mind in this case has a primary set of objectives. That's it, man. If how they get there doesn't really matter as long as it's done right and meets their requirements. So that's so you guys figure that out, right? And then now at some point, and we'll kind of let you detail this out, you're applying to and then getting accepted into Y Combinator. So how does that experience shape your strategy, the growth of the company, and then of course the ability to scale within the industry?
Yeah, Y Combinator was a childhood dream of mine. Right? Like I've been reading Hacker News since it like came on as a website, you know, and I was just consuming it day after day. And when we applied and then interviewed and got in, like definitely a life goal achieved, which is pretty awesome. But then then you always, like when you achieve those goals, you always make this realization that like, oh, that's just the beginning. And so Y Combinator has done a number of really cool things for us. First, world-class network, right? Like there are so many cool people that I can just email and get an answer in 15 to 20 minutes about business models, about technology, and it's all there because of Y Combinator. It's also been great for recruiting, right? When people see the Y Combinator badge, they feel at peace, right? Like there's reassurance there. And so that helped a lot from a recruiting standpoint. I think the Y Combinator has been very focused on software, particularly when we joined, right? Like there were only a handful of robotics companies that have ever gotten into Y Combinator. And so a lot of their main road is very software driven. And so there's definitely good things that we learned there. Try and ship as early and as fast as you can, right? Stuff like, get customer feedback as quickly as you can. But there's also like some of the more like data driven stuff that they can provide around this is what you need for a seed raise. This is what you need for a Series A raise. They just don't have the data for it yet. And I think in, a year or two, given their newfound support for hardware, like they'll have that data to help guide companies.
Excellent. So that and then continuing on the path, right? So your Y Combinator, really valuable experience. Primarily, it sounds because of the network and the access that you have. So for anyone in the audience who doesn't know, so Y Combinator is essentially a startup incubator. And Barrett, just correct me if I'm wrong on any of this, right? There are these batches, 2 or 3, I guess 3 a year.
I think they're up to 4 now.
Up to 4. So I guess maybe aligning with the seasons that incubate these startups, help provide, a preset amount of funding in exchange for some equity, right? The network, so on and so forth. So you guys get in, go through the process, and now you've got somewhere like you got a company and you have a product. So can you just explain to the audience how BotBuilt's robotic framing system works? Let's say just from inception of a project to a finished product.
Yeah. So fundamentally, the process starts with a floor plan. So when we were starting, one of the key things that we wanted, there were kind of 2 foundational ideas. One is the American consumer wants their home. They don't want just a house. And so that drove us to build technology that can accept any floor plan, right? We want to be able to build your home. So you bring us a floor plan for a 1,200 square foot ranch, or you bring us a floor plan for a 5,400 square foot custom McMansion, like we got you. And that's key because that's how the American market operates. We bring in that floor plan. From there, we ingest all of the information using AI that's relevant to the framing of the house. So window locations, door locations, header sizes, any beams, where your foundation's located, and then all of the roofing information as well. That lets us do a couple of really cool things up front. We can give you a very accurate material takeoff for a house in under 24 hours. Right now, lumber yards take somewhere between 2 to 4 weeks to do that. And so we've actually now we've monetized that part of our software. We started selling that in April. In May, we got our first customer, and in June, we doubled our revenue off of just that. Just give us a floor plan, we'll give you all the materials, and we can turn it real fast. And the things that the lumber yards really like about that is just their main bottleneck is quoting. And so when they can take that main bottleneck and shrink it from 2 to 4 weeks down to 24 hours, that's massive for sales. But that's just the first step for us, right? We get all that information, we build out a CAD. From that CAD, we can estimate all the materials. That's one off ramp. But then to keep going down the route to the robots, we take that CAD, it specifies all of the pieces of lumber down to a 32nd of an inch on precision. And then we also have to specify every single nail and its pattern, because the robots need that to build.
Because there's no inference like we have
right
up here.
Right. And so the next portion of the tech stack is my thesis work from Duke. It's figuring out in what order should we do all of these high level behaviors so that we can actually go and build this house. And that's assuming like ideal wood, right? Which doesn't exist, but it gives you all the like high level, it answers a lot of the high level questions. Then we go and we give that plan to the robots. And while the robots are operating, they're picking up lumber from just a bunk of lumber. They're analyzing the lumber, saying, all right, it's bowed, twisted, it's got some wane, sets it down. It's using computer vision and on-the-fly motion planning to adjust how it's moving and correct all of the imperfections that are in that lumber, nailing it together, then going on to the next chunk of wall. We stack up all of those walls on the back of a truck, ship them out, and carpenters on site put it together. It lets their on-the-site process go from 1 to 2 weeks down to 4 to 8 hours. And the big win there is that framing, when you're all done with framing, you're at the dried-in stage. And that's really important because you become weather independent for the most part, right? And a lot of it can become parallelized. Your electricians can get in there, your plumbers can get in there, and you really just like schedule risk really defines a lot of the problem in construction. And by getting rid of that schedule risk with robots, you can have a much more deterministic process.
So then where you guys leave off, right? And I'll just ask a couple questions along the way, right? Because somebody needs to provide the foundation of the home before you guys can, set your sill plates and then start building up.
Yep.
Right. But then somebody needs to come in, right, and put a roof on, put windows in, right? So you guys are focused for wood framed structures. But your value proposition to builders is eliminating, right, like you said, schedule risk, because you compress the timeline to being dried in so much faster. What other benefits for your customers?
Yeah. Usually 20 to 40% savings on material because we're able to account for everything. And then we also see a significant reduction in errors. So the framing inspectors around here love when they see BotBuilt wrap because they know the house is going to be done right.
And then I guess from like the human component of like, hey, building the relationship, trust, et cetera, because this is obviously like it's new technology, and 5 to 10 years in construction could be considered a short time frame. So like, how do you take those very human elements of like trust that just take time to get your customers on board with what is a new technology and way of doing things?
Yeah. Fundamentally, we just start small, right? Like our builders start with a takeoff. It's $300 a plan. It's something we can get you an answer for in 24 hours. And they can compare it to their old way of doing takeoffs. And we spent a lot of time thinking about what are all of the things that somebody wants to see in order to validate that the design is correct, right? So we provide a bunch of different ways to validate that what we're doing is correct. And that builds a lot of trust, right? It's just, and then also acknowledging that builders all have their unique process and none of them are bad. They're fit to different customers. And so when we come across a process that we've never seen before, we'll just ask a bunch of questions. We built our technology to adjust very easily to different processes. And then we'll just adjust for it and keep building with the builder, right? And if we have a new way of doing it, we'll bring it forward and we'll say, hey, here's a different way of doing it. Here's what we think the benefits are. What do you guys think? And sometimes they'll say no. And then after a couple of homes, they'll go, actually, could we try your way? And so it's just, you got to meet them where they are. Because like construction is littered with a history of good ideas that didn't work.
Construction is it is not a fail fast industry. It's not a piece of software that you can ship and then provide updates to pretty quickly, right? You get one shot.
Yep.
And I think
Yep.
I like your guys' approach because you're taking, I guess, the history of how construction has been, right? Injecting the human element to make your new technology successful.
Right. Yeah. When I think about it from a cultural perspective, and like when it's 110 degrees outside and 80% humidity, and they're still building a house, you have to realize these people are just inherently tough, right? Like they're getting the job done in those kind of conditions. And so when you have a conversation with them, there's also just like an internal acknowledgement that you have to make to yourself. Like, these dudes have been through some stuff. They've seen a lot. And so like, be okay with a little pushback, right? Like it doesn't mean that they don't like it or they don't think it's a good idea, but like you have to have some real emotional fortitude to build a house in conditions like that. And so, it's not an easy customer to win.
Speaking of that, right? So the skilled trades. Think about how many go into creating a house, right? Concrete, masonry, carpenters, electricians, plumbers, and that's just a portion, right? So,
yep.
We talked about, I think what you said, 3 licensed electricians in the state of North Carolina under the age of 30.
Yep.
So, what role do you see robotics and automation playing in the future of construction, residential or commercial, particularly in addressing labor shortages and then the boost in efficiency?
Yeah. I think fundamentally the problem construction has is that for the last 50 years, it's been portrayed as a low status profession. And that's just fundamentally wrong. And robots help us address that cultural issue by making construction sexy, right? Because the next generation wants to do cool stuff. And robots are cool. So robots building homes, that's a way for construction to gain some of the star power that tech has enjoyed for the last 20 years and apply it to a deeply necessary area of the American economy.
And I think, and as you go through life, right, you rent, you buy your first home, etc. Like, I think those problems become more apparent because it's like, for just a middle class kid, right? It's like, I've always had a roof over my head and I didn't have to worry about any of that stuff. And then later in life, it becomes like pretty apparent, like, well, this stuff is expensive, huh? Maybe like providing housing to people is a necessary and worthwhile endeavor. But the fact that you guys are then making that sexy and then showing the next generation out there is a way, particularly, you hear these discussions about like AI replacing jobs, right? But there's such a demand for construction, not only in this country, but across the world, that I don't see this industry being devoid of people anytime soon. But you guys are providing a way to make it more enjoyable for those who are still here.
Right. Exactly. I think it's like a fundamental, maybe not fundamental. It's a widespread belief that robots mean autonomy, right? And there is a lot of truth to that. But if there's one thing that I've learned from building 20 different robots, it's that there's always going to be a portion that the human has to help with in the foreseeable future, right? Maybe in 100 years, we'll have every physical thing ever automated. But for the next 10, 15, 20 years, there's going to be stuff that humans have to do. My like general heuristic is like, if it's a physical, rigid body, robots can probably handle it. If it's soft and squishy, it's probably going to be a human. And there's great advancements being made in AI right now, whether it's imitation learning or reinforcement learning, large language models. All of these things are great advances, but they're still pretty brittle, and they're still very specific to the environments that they've been exposed to. And all of those methods are deeply data hungry, right? Like the ChatGPT has had like 10 billion data points shoved into it. Like I've got, for construction data, I've got tens of thousands of points. A great example of this is like if you go on YouTube and search how to make spaghetti, like that's a 5-minute process that we all know exactly how to do. There are 100,000 videos of how to make spaghetti. If you look up how to frame a house, a much longer process, there's 1,000. So there's this massive difference in data.
And I bet what those 1,000 videos probably don't portray the minutes or hours of the nuance,
right,
to actually get it right. It's because and that's why, like, when you train young structural engineers, like getting them on site is one of the most important things that you can do, because there's a lot of nuance and the little things that make up the job. And in the same way, if you take that back to, I would say, training AI or whatever we want to talk about, to me, it's that nuance, and that's what's not going away from the human touch anytime soon, right? Because, like, I mean, think about how expensive it is to train anything on physical world data. You guys know, you guys have a sense of how that goes.
Yeah. It's very early on. We got the closest thing that I think we can ever get to an oracle on construction robotics. This guy started as a CB, then became a laborer after getting out of the Navy, and worked his way up all the way to becoming a superintendent. Spent 20 years doing that, and then decided, I need a break from construction. So he went into robotics, and he spent 20 years working in robotics all the way up through DARPA Grand Challenge. So, like, competing at the highest level internationally for driverless cars. And I found this guy online, and I just said, hey, man, would you mind, like, coming and talking to us? Tell us, like, what's the one big thing that kills construction robotics? And he graciously agreed to come and gave us the benefit of his experience. And there was one thing, his answer to my question of what was the one big thing that's going to kill us. He said, Barrett, there isn't one big thing. Construction is 1,000 little things that, if not all done perfectly, will destroy it. And so what we're doing every single day is finding what's that new one thing that we're going to nail perfectly today.
Really well said. And not sure if the pun was intended, right? Because you guys frame houses down to the nail. So that was some good parting words. But Barrett, this has been excellent, really informative for me. So thank you again for taking the time. Any final pieces of advice you'd like to share with the audience, particularly this group that's looking to bring technology-driven solutions into their organizations?
Yeah, I would say just keep going, and make sure you understand the people involved, right? Because at the end of the day, it's the people involved that will get it across the line. It's not the technology is secondary to the people.
I love it. And I also try to take that lesson moving forward through a lot of unfortunately hard learned experience trying to put the technology before the people. But I mean, as long as we're in a world that is built for humans, by humans, and robotics, I think that is great advice to have. Again, Barrett, thank you for taking the time to join us today. What's the best way for the listeners to connect with you if they have any questions or want to learn more about BotBuilt?
Yeah, they can email me, barrett@botbuilt.com. They're on X. Follow me. I'm always throwing spicy takes out there on X. Come tell me where I'm being dumb.
And if anyone has the courage, will include links to all of Barrett's socials and BotBuilt website, as long as his email, in the show notes. And Barrett, thank you again so much for taking the time.
Thanks for having me.
Absolutely. Until next time.
Please remember, you can find the show notes for this episode at aectechpodcast.com. There, you will find a summary of key points discussed in today's episode, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, I wish you the best in all of your engineering and technology endeavors. Thank you.